Okay, so moving away from three variables simultaneous for the minute before we get to examples in context, I just wanted to give a small bit of intuition for the simultaneous equations involving one linear, and one quadratic equation. So let's consider a completely arbitrary linear and quadratic simultaneous, which do have real solutions. Once we get to quadratics, I will formalize what that means, though if you have gotten to quadratics by this point, if your school does a slightly different teaching order, you will have met this idea of real solutions. So let's draw completely arbitrary quadratic. So this is some y is x minus a squared plus b. And I'll try to draw that line a little bit straighter. Here is the equation y equals sum mx plus c. Now, note that in the case for real solutions, we will have two intersection points. Now, that corresponds to two valid solutions to the simultaneous equation. Though, for this point, just note where the solutions are. So, the solution essentially has the intersection, I'm going to call them capital X1, capital Y1, as well as capital X2 and capital Y2 for the bottom one. Now, note that capital X1, Y1 and capital X2, Y2 are on both of the lines at the same time, or in another word, simultaneously. So in fact, if I were to write y equal to mx plus c, we know that this intersection, this equation intersects the other equation at two separate points. I've written them both in terms of y because it makes sense that if the two y coordinates are the same of the intersections, then it should be that the two x coordinates are the same. So since y is equal to y, particularly at 2 points, then what we can do is we can set the linear mx plus c equal to the quadratic, which is the a times, well, I didn't have an a in there, but I mean, I probably should, but as I never, x take away a squared plus b. And from there you just proceed. So the trick for this is we're instead going to use the substitution method, which I did mention previously as pretty much the method for this kind of problem. So essentially what we have to do is we want to write y as a function of x or x as a function of y. Whatever one is easiest to do. You isolate one of the variables and then you want to sub f of x, or in some case f of y, into the other equation to solve for the xy coordinates of intersection. So that's effectively what we do. Now, importantly, the first step, by writing y equal to f of x or x equal to f of y, this is what we do for the linear equation. I might make an extension video just to show that why that's the case. Though, if you're not bothered in watching the extension video on what the simplified reason, it's because rearranging a linear equation is much easier than rearranging a quadratic equation while trying to keep all the same information. So take the linear equation, rearrange it, and then sub it into the quadratic form. And from there, everything collapses nicely into a simple quadratic that we can then use to solve for the points of intersection.